This is question 5, the physics combined higher paper. The part A is recognising the symbols. The thermistor is that one. First one was your light dependent resistor, an LDR. Second one's your variable resistor. And the last one's a diode. Okay, if you're worried about which way the direction of the current goes through a diode, it goes in the direction of the arrow, the positive to negative, that way. But the answer to this one, thermistor. Now when we look at these questions, we've got to describe the trend. You don't just say what happens. First thing you do, look at the x-axis, then the y-axis. Whatever changes in the y-axis, the x-axis changes whatever happens in the y-axis. So as temperature decreases, we can see, sorry, as temperature increases, we see resistance decreases, which is what we expect in a thermistor. You also need to look at the shape of the graph, the next thing. So here we can see it's non-linear because it's a curve. Okay. So to find the rate of change of anything with time, you need to do your tangent. Now here we're drawing a tangent to the curve at 30. So it should touch here. Then we do a nice big triangle. Now in maths you're taught to take 2 points in a line. Don't do that in physics. In physics you must draw a big triangle. The biggest triangle you can do, so choose a couple of points on there and draw a big triangle. Then do the change in the y over the change in the x. So here we have minus 0.092 kiloohms per degrees Celsius. So you're given the marks if you had a range from 0.087 all the way up to 0.097. Okay. Now next one here, we've got an experimental question. Now it doesn't matter what the experiment is, think, use your brain, what we're going to need. Right, we want to measure the temperature of the water. The heater's here. So a couple of things we can do. We can see that there's a lot of water between the heater and there. So we could put that closer to look at the thermistor. Or we could stir it. Yeah, we've got a stirrer. Yeah, the stirrer's going to stir it. So one improvement to there. So you could, suitable improvement is stir it, and that will keep even temperature. Thermometer closer. Thermometer closer. So the temperature is the same. Oh, I don't know what's happened here. Okay, temperature is the same as the thermometer. As thermistor. That's the idea. Or we could have used a digital thermometer. Okay, and that's got a better resolution. And resolution's got to do with precision. We'll see that in the next part of the question. Now, the next part of the question, it's showing you different an ohmmeter and an ammeter and a voltmeter. Okay, so method 2 gives more results than method 1. Explain why. Now you had to explain why. The reason being, look at the display. The displays are two. So here we've got 5 digits on the voltmeter and 4 digits on the ammeter. Okay, so we can give many more decimal places or significant figures compared to the 2